Let's continue with tutorial 5b, question 1, part 3. In this part, we are asked to derive the difference equation. The only information we are given is again the impulse response. And remember, this impulse response is finite impulse response because you only have 3 values, and after that the rest are 0. Let's see how we can answer this question. We again use this idea. We draw the block diagram with this impulse response, and then we now take the z transform of this impulse response to give us h of z. That's a special name for this term. This is called the transfer function, and the transfer function can be gotten by 2 ways: directly by performing z transform on the impulse response in this manner here. This is the z transform of the impulse response, and in this particular case we can write it fully because the impulse response is finite. It only has 3 terms. Now we then make use of the second way to get h of z, which is this equation over here. In this particular case, the z transform of h of n can also be gotten by y of z divided by x of z. So now we take the opportunity to write y of z over x of z equals to the expression that we got from the z transform of the impulse response. This allows us to generate the difference equation. How? Well, what we do is that we move x of z to the right hand side, and therefore we get this expression over here. 1 times x of z is x of z, 2 times z minus 1 times x of z is this expression, 1.25 z minus 2 is this expression. Now, we now can perform inverse z transform. Y of z inverse z transform is nothing but y of n. So this is easy. X of z inverse z transform is x of n. 2z minus 1 x of z is nothing but 2 x of n minus 1. And 1.25 z minus 2x of z is nothing but 1.25, which is the coefficient. The z minus 2 become xn minus 2. Okay, so now this expression over here is the difference equation. So actually from this difference equation, I'm going to again show you how we get this MATLAB expression of B's and A. Remember that in MATLAB, if you type the word help filter over here, you will see that the filter is expressed by this expression over here. So type help filter in MATLAB, you'll read what the filter means in MATLAB. The first thing you must remember is that the MATLAB has entries starting with index 1 and not 0 for its vector notation. So what we have is this difference equation here. 1 bracket a bracket 1n is equals to b1 xn, b2 xn minus 1 plus plus plus, and so on until b nb plus 1 times x of n minus nb. So this expression here is the output with respect to the input and the past inputs until whichever past inputs you want to use. And it also uses the past output, and the coefficients are minus a2 yn minus 1. So it's the past output, past second output, past the output, and until whatever past output you want. And you'll realize that then we have now the vectors of A and the vectors of B in this expression. And now if you compare the coefficients of this difference equation with the MATLAB, then you realize that B1 has the value of 1, B2 has the value of 2, B3 has the value of 1.25. And these 3 values are then returned in this vector here. So this is B1, B2, and B3. And what about the A? Well, we have A1 over here, and there's only A1 because there is actually no other feedback. So the A coefficients has only 1 entry, and this is A1. So now let's again look at the MATLAB's difference equation. This is the MATLAB's difference equations, and the equations of B's and A's are from this expression here. Thank you.